Hi, everyone, and welcome to this chapter. In this chapter, we're going to talk about mixins and what they are. Some Flutter developers seem to be a little bit confused about what a mixin is and how it is different from an abstract class. So, although it is impossible to explain everything in just one video, I'm going to try to explain three very specific scenarios where you would want to use a mixin instead of an abstract class. So as you've watched the previous video, if you watched the previous video, you'd know that an abstract class can have abstract methods and it can have abstract properties. Plus, it can have functions or methods that actually do have implementation, so they're not abstract. And mixins follow in the same path in Flutter or Dart, actually. They allow you to create abstract methods. They allow you to create abstract properties, and also they allow you to have methods that have logic. But mixins have some other properties, and for instance, they can be constrained on particular classes. So you can create a mixin, for instance, that can be placed on a specific class, and anybody wanting to use that mixin in the future will have to extend that aforementioned class. So we'll talk about all of these in this chapter, so don't worry about this. So we're going to talk about mixins and also how best to utilize and use them in your applications. So let's go ahead and create our project. I'm going to do some reshuffling here on the screen. So let's say we're going to say Flutter create mixins course, and I'd like to add an organization always, SE Pixology, which is my organization Pixology. So let's see how that goes. And let's just cd into that folder. So I'm just going to say cd cd mixins course. Okay, I'm going to bring up Visual Studio Code here. And since Visual Studio Code has a built-in terminal, we don't need that terminal window anymore. So I'm going to close that. Now, we need a simple scaffold application here, because if you look here in our main Dart file, it is set up with like a counter application. So there's a lot of code that we don't need. So I'm going to delete all that and just create a simple scaffold application. So this part is just Flutter code, to be honest with you. So it's not relevant for this course, but I just want us to have a simple Flutter application with hot reload and hot restart so that we can actually test our Dart code. Okay, so if you're not familiar with Flutter, that's also fine. I have a free Flutter course, about 36 hours of content available on YouTube in my channel. So please go ahead and watch that if you want to. So I try to stay away from explaining Flutter code in this particular course, which is more basically targeted towards Dart developers. So let's go ahead then, as the caption also says, let's go create a little test function in here. We're going to call it, oops, if I can spell. I'm going to say void tested, and this is going to be like our test bed basically. So, and then in your homepage, right in the build function, we're just going to call that function, okay? Just like that. So every time we do a hot reload or hard restart, this function is going to be called. So I'm going to bring up select device here, Flutter, and choose a simulator and do run without debugging. So that process is ongoing now. So it's going to run the application. And while that is going on, let's go ahead and also add a Git repository here so that we can commit our code. So this is just some boilerplate stuff that we had to get out of the way. So as you'll soon see, we also need some basic login functionality in this chapter. So we're going to use my favorite extension on object for logging strings onto the screen using the log function in Dart developer package. So I'm going to add that here. And I've talked about this before, how this code actually looks like, and you can have a look at it. So it allows you to basically invoke a log function on any object in Dart and get its string representation printed to the debug terminal or the debug console. So what we're going to do now is to create, just to get to the point of this chapter, we're going to create a simple mixin, and it's just called can run. This can run mixin is going to have a property called speed of type integer, and it's also going to have a function which is called run. So the property that it's going to expose is it has no value. So mixins can put constraint on their defining or their implementing classes to say, for instance, I'm a mixin, I need a property called XYZ of this type. Any object that uses me uses this mixin will have to have that property. So it is a way, it's kind of like abstract classes, so they can put constraint on their implementing classes. So let's go ahead and create our can run mixin. I'm going to increase the size of the window so it's a little bit more readable if you're on a mobile device. So let's go ahead and say mixin can run. Okay. And let's go ahead and add this property that I just talked about. We're going to call it int get, and we're going to call it speed. So you can see here, we created a mixin called can run, and it expects any implementing classes to have a property called speed. So of type integer. All right. Then what we're going to do is to go and add a run function to this mixin. And this run function is not going to be an abstract function, meaning that it is actually going to have logic in it. So let's go ahead and add that, say void run. Okay. And then we're just going to say running at the speed of $speed, you see, because speed is a property of this mixin, so it can be used. And then we're just going to log this using our little log function. Okay. So this mixin on itself is not so useful. We're going to actually use it inside a class, and we're going to use it inside a class called cat in here. So let's go ahead and create a little class in here, and we're calling a class cat. And we want to bring in this mixin into the cat class, meaning that a cat, according to this program, can run. A cat can physically run. So since the running functionality is defined inside can run mixin, let's bring it into the cat. But how do we do that? We can't extend the mixin. What we have to do is to use the with keyword. Say cat with can run, like that. So that's how you bring in a mixin into another class using the with keyword. And you can actually bring in multiple mixins into the same class. So if you, for instance, had a mixin can walk, and then you had a walk in here with some function, you could actually go into your cat class and say can walk. All right. So just know that extends, when you extend a class with another super class, you can only have one super class. So that's object-oriented programming in Dart, that you can only have one super class. However, with mixins, you can bring multiple mixins into the same class using the with keyword. Okay. Let's remove this can walk mixin, and let's address this little error that we're getting here. And you may be wondering what this is. Let's just read it. It says missing concrete implementation of getter can run speed. Try implementing the missing method or make the class abstract. Okay. So making the class abstract is not a choice. We actually want the class cat to be a real class that we can instantiate and run without a problem. So how do we fix this problem? You can see in here, the can run mixin created a constraint on any implementing classes, saying that if you want this void run function, you have to have a speed integer value. So let's go ahead and ask Visual Studio Code to help us with this. So you can see it says override int get speed. And then we could just say the initial value, for instance, only factory concern can specify. Okay, so something like this, int speed 10. So here we basically said, okay, we're overriding the speed, and it's not just a getter in this case, it's actually a getter and a setter. So it can be a property that can be written to, okay, like that. So now we have that class cat, and it uses can run, and it has a speed of 10 initially. And yeah, you can just instantiate it, as you'll soon see. So let's go ahead in our tested function in here and actually create a cat instance. So let's say final cat is an instance of cat. Then we can say cat run. You can see you have the run function in here simply because cat is mixing in the can run mixin, and therefore has the run function. So let's then go ahead, since our our speed property is read and write property, so you can actually write to it as well from the outside. So it's not just a getter. What we can do is now to change that speed. So we can say speed is 20, and then we say cat run again. Okay. So we can now see the output. It says running at the speed of 10. That was the result of calling run the first time in here. And then when we change the speed to 20 and then say cat run again, you'll see that it says running at the speed of 20. So first 10 and then 20. Okay, perfect. So that was for the first example of how to use Mixins. Let's go ahead and commit and tag this code that we've written. So git add all and git commit step 1, and I'm going to say git tag step 1 as well. All right, so now our code is committed and tagged, as you can see in here. So git tag, we have, you can't see it, tag step 1. All right, that was our first example. So what we're going to do now is to use constraints on Mixins. As I mentioned, Mixins at the moment, for instance, are can run Mixin is just a free soul. It's just sitting there waiting for anybody to mix it into themselves using the with keyword. However, a mixin can also put constraints on its its implementing classes by saying that I'm a mixin that can only be mixed into specific types of classes. Okay. So let's go ahead now and demonstrate that. Let's go ahead under this log and create an abstract class. So let's say class, abstract class, animal, like this. Okay. And I'm also going to go into my notes. Sorry about that. I'm just going to check out a specific code as well. Check out step 2, because I have all the code ready basically in here, and I sometimes may want to copy paste stuff from there. So I always have it ready to my left-hand side. So this abstract class is only going to have a constant constructor. So let's say const animal. Okay, so an abstract class called animal, and it has a constant constructor. Great. So what we're going to do in here, we're going to say this can run mixin from now on is only going to be limited to any class that extends or subclasses animal. Up to this point, this mixin has been a free mixin, can be mixed into any class. But now we're going to say, no, it's a mixin that can only be mixed into subclasses of animal. And that means direct subclasses or like down the hierarchy subclasses. So it doesn't necessarily have to be a direct subclass of animal. So let's say this one, mixin can run on animal. Okay. So now you can see we said, yeah, and Dart is basically happy about that. Says, okay, yeah, this is a mixin that is only valid on types of animal. So you can now see that we get an error directly after adding this on animal here that says can run the mixin can't be mixed into object because object doesn't implement animal. Try extending the class can run. So that's unfortunately, I mean, is not really the solution for us, because what we want is that to say, yeah, we want to use can run, and also we want to be an animal. So what we need to do in here is to make sure that cat actually extends animal. So extends animal. And now you can see, now after extending animal, you can actually use that can run mixin. So let's go ahead and actually see how this works by adding another class that is not of type animal. So let's go ahead and add a class in here. We're going to say class animal, class dog with can run. So in here, what we can do actually is to add a little piece of code in here that adds the speed, which is a necessary constraint for a can run. But I just want you to see that even though we're basically satisfying all the constraints for can run's internal implementations that says that you have to have a speed property, at least a getter, even though we've done that, we're still getting this problem saying that can run can be mixed into objects, simply because any class that you create in Dart is implicitly of type object. So even though you don't say extends object, it is by default of type object. All right. And here we're seeing this error saying that, yeah, you're not of type animal because can run expects you to be of type animal. Okay. So that's our class dog. And you could see now it cannot use can run simply because can run is constraining any object that implements it to be of type animal. So now that you've seen that example, let's go ahead and commit this code. So I'm gonna go ahead into terminal and say git add all git commit step 2, and we'll tag it as well, git tag step 2. Okay, so that's that code. Let it be like this, let it have the error. It's completely fine. So what we're going to do now is to use, I mean, right to this point, we've been like looking at some examples that are kind of like fun to work with, but how often do you go and create a dog and a cat class? It's, I don't know any developer that's had to do that unless you're maybe a game developer or something that you have classes for your objects. So it's not very real life example. And I kind of wanted to start this chapter with this example, with these two examples, because they were easy to understand. But let's go ahead now and create a little bit more real life example. And we're going to, for that, delete all the code that we've written in here except for our log function in there. Okay. So what we're going to do in here is to, let's see. Yes. So what we're going to do in here is to add an extension on object that allows any object to retrieve the contents of a URL. Okay, what we want to actually achieve at the end of this chapter, at the end of this example particularly, is to be able to define API classes that simply specify their URLs, and the rest is done by extensions and mixins. Okay, so that's like the goal. Like, let's say that you define a list of people as a JSON, and this JSON, for instance, is sitting somewhere on a server. Let's say it's served by Django, and then you serve this to your Flutter application or whatever application you have, and you want to define an API that says in your application you can say, here's my API that can get this list of people and extract that response as a string, and then it can be parsed as a JSON. So what we're going to do now is to actually go ahead and define these. I know it's a little bit abstract, but you'll get the point by the end of this example. So I'm going to bring my examples in here as well so I can explain it to you. So let's go ahead and create our little extension. As you can see at the bottom of the screen, it's called extension gets on URI on object. So let's go ahead and define this extension in here. I'm going to say extension get on URI on object. And then we're going to say, I mean, to be honest with you, this could just be get or something, but we're just going to call it this for now because extensions with names like they need to be distinct. So what we're going to do in this extension is simply allow any object to pass a URL to us. And this URL is going to be of type string. And we're going to return the result of HTTP client response to the caller. And for this, we're not going to use any like HTTP library. We're just going to use the HTTP client that's built into Dart's async, I think. Is it in Dart IO? It seems like it's in there. Yeah. So let's go in and import Dart IO in here. So let's say import Dart IO. Okay. And in here, then we're going to go ahead and say future HTTP client response like that. And let's just call this then get URL, just like this. And after doing that, what we need to do is to define the argument that is passed in here. And also we're going to return the HTTP client response. So there's quite a bit of code that we have to write in here, but that's completely fine. So let's go ahead and say we have a URL in here. And let's make this an arrow function. So let's say that we create an HTTP client in here. Okay. And then there's a function in here called get URL. And we say URI parse, and we parse this URL that comes in like this. So we get the URL, and then we have the responsibility to close that request. So it's a little bit of a strange API, to be honest with you, but that's okay. So this is not your response. This is your request. And what you have to do in here is just to close it. And then the response of that close function is the future HTTP client response. So this is kind of like JavaScript-y. And to be honest with you, I'm completely fine with that because I really love like the way JavaScript works actually with futures and promises basically. So to me, at least, it's really nice API. So Here's our API. As you can see, we just say HTTP client get URL, and we get that given URL in here. And then we're saying we get the request, and then we close the request, and we're good to go. Maybe we shouldn't put a comma in there. So something like this. Or put it, comma. Yeah, maybe with a comma is also fine. Okay, so that's what we had to do. So now we can call the get URL on any object and pass the URL into it, and that will give us the future. Okay. So what we need then is to create a little mixin, and we're going to call this can make get call. So this is a really cool mixin, and you'll soon see that what it does is it expects any type that implements it to have a URL. You saw what we did with the previous can run mixin, in that we said can run constrains its defining types or its implementing types to have a property called speed. And we're going to do exactly the same thing with this mixin. Instead of speed, we're going to say any implementing type has to export or has to expose a URL. So let's go ahead and say mixin and make get call. Okay. And let's just say string and get URL, something like this. Okay. And what we're going to do is to expose a future in here that literally grabs a string. So we're going to say future. So it uses this function in here, get URL, gets the response, and then parses the response as a string, UTF-8 string, and then gives it back. Okay. So this is perfect for parsing JSON if that's something that you're doing in your project. So let's go ahead in here and then say we give back a future string. Okay. And this is a little bit of like going off the tangent here, but when I do like functions, when I create functions that are actually doing something valuable, I like to mark them with something called use result. And use result is kind of like a meta programming for Dart, but what it does is that it enforces, it kind of gives an analyzer issue or warning to any user, any programmer calling this particular function that is marked with use result, saying that, hey, you're just calling this function, but you're not actually consuming this result. And that kind of like removes 50% of all mistakes in programs where a user calls a function thinking that it does something internally, but it actually is expected to return something valuable. So let's go ahead and import Dart meta. Actually, it's called, is it package meta? Yeah. And let's go ahead in here and mark this guy with use result like this. Okay. So this function is going to be called get string like this. And let's just make it an arrow function. And for now, I'm just going to say this function calls get URL. You see, all of a sudden, get URL is available to this mixin, even though we didn't say it extends object. But remember, mixins are kind of like abstract classes. They are actually abstract classes, and any class, as I said, is implicitly in Dart extending object. So this get URL is all of a sudden available to you, even though it's in an extension on object. So perfect. So let's go in here and then say we get the URL, and then we say then. So this is the response. Okay, I'm going to call it resp. And let's just say we transform this. We say resp transform. And now we have to import actually UTF-8 in here. So we're going to import Dart convert. So import Dart convert. Okay. So we're going to transform this guy with a UTF-8 transformer in here. So we're going to call it UTF-8 decoder like that. And then we're going to join the result at the end so we get a string like this. So and let's clean up the code a little bit. So put a comma in here, and then put a comma in here, and perhaps a comma in here. So it's a little bit cleaner to look at. And I hope that you can see the code in here. So I'm going to make it a little bit smaller so you see the code in its entirety. So can make get call uses get URL, puts the URL in there, and then when it gets the response, remember this is an HTTP, what's it called? HTTP client response. This client response then has a transform function that allows you to transform the result of that response, like the data in it, to a specific decoder. Here we're using the UTF-8 decoder. And if you look at this transform, it returns a stream of S. And when you say join, it's literally just, let's have a look at it. You see, it returns a future of string. So this is how we created a mixin that can expect a URL and it can return a future of string. So to put this to test, let's go ahead and create a list of people that we can actually basically make an API call to. And it is a bit of a struggle really where to put that. I could go ahead and like create a little server in here with Django or like Node.js and Express, but that's a lot of work. So what we're going to do in here is to go and use an extension in Visual Studio Code. It is called Live Server. Okay, so I need you to please go ahead and install this Live Server extension. For me, it's already installed, so I don't have to install it again. After doing that, what we need is to go ahead in our project and let's go ahead and create a folder, and I'm going to call it APIs. Inside APIs, I'm going to create a new file called people.json. I'm going to create an array in here, and the first object is going to be name, and we're going to say age is 20. Okay. Let's go ahead and create another object in here and say name bar, and age is 30. Like that. And after saving this, what we can do in here is to bring up the command palette in here and just type live server in Visual Studio Code and say open with live server. Okay. So as you can see, then this creates a live server that serves the entire contents of my project inside my own computer with localhost. So then I can go to APIs and then people JSON. And as you can see, then this is a URL that I can actually call. So if I open up a new tab and just paste it in here, you can see that it serves that JSON to me. Okay. So let's copy that URL and keep it in mind. Then what we're going to do in here is to create a new class in here that is going to consume that API. Okay. We're going to call it getPeople. So let's go ahead and create this little guy, and we're going to say it's an immutable class. And we're going to say class get people. And in here, now we're going to bring in that mixin that we've created, this little guy, can make get call. Okay, so we're going to say with can make get call. And then it says, okay, but what is your URL? So let's create a constant constructor for this guy to say, yeah, this class doesn't change internally. And then we're going to say, okay, we're going to override that URL. So here we go. So then I'm going to paste that URL from localhost just like that. Okay, so you see how easy it is now to create like a get API. It says get people is, it can make a get API call, and its URL is this. How beautiful is this, like to define your APIs just like this? So what we're going to do then is to go ahead and consume this guy. Okay, so let's go inside this tested function and say final people is, we're going to then await on this API call, right? This get string. So we need to make this tested function an async function. I'm going to say await on const of get people get string. And then we're going to say people dev tools. Actually, we could say people.log. All right, because if you look, people is now an actual string because the result of get string function is a future of string, and by awaiting on it, we're actually getting its result. So I'm going to bring up the debug console in here and press Command S, and then you can see the result being printed here to the screen. So it actually retrieved, it went and did the API call and retrieved the result and came back with the actual string. Perfect. So now that that is done, let's go ahead and commit this code. Before we wrap up this chapter, we say git add all like this. Oops, git add a, git commit step 3, and then we're going to say git tag step 3 as well. Something like this. Perfect. So I hope you could have some value by watching this chapter where we're talking about mixins. And mixins are very similar to abstract classes. They actually are abstract classes in their core, but they don't have constructors, and they can have constraint on them in saying that they can be constrained to specific classes only. So that's the difference between mixins and abstract classes. So I really hope that you enjoyed this chapter. If you have any questions, please let me know. There is a Discord group As you may know, if you go to the playlist for this Dart course, you'll see that there's a Discord group that you can join if you have any questions. And there's more than 500 people available in that Discord group, which you're more than welcome to ask your questions there. Or you could just ask them here in YouTube as well, and that'll be fine. So hope you enjoyed the video, and see you later.